Hello, my name is José Ramón Martinez. Today I'm going to talk about the SimWare Simdeveloper. Simdeveloper is a tool that is integrated into the framework called SimWare Framework. Well, I work for NAVANTIA. I am the head of pre-sales. The agenda for today will be: first, I will speak about how Simdeveloper fits into the SimWare framework. Second, I will center in the SimWare Simdeveloper tool itself. Then I will show the real thing, the Simdeveloper. I will show how to use this tool in the real situation. We are going to use it. Later, I'm going to talk briefly about eHost, because eHost is quite important in the context of Simdeveloper. And finally, I will make a brief summary. This will be about 75 minutes. Well, for starting, I want to talk about how SimWare Simdeveloper fits into the SimWare framework. We have to understand what is the SimWare framework and what is this tool we are talking about going to do in this framework. Well, SimWare framework is a framework for enabling distributed simulation. We are going to make real-time distributed simulation. We are trying to go as fast as possible over nodes that are distributed in a network. We have tools for modeling. We have tools for running. We are centered, and this is quite important for Simdeveloper, on making models that are clock wall simulation models, event-driven simulation models. We will have a scheduler. We will have a central server that will send the ticks to these models, so that these models will answer to this tick. Also, we have gateways to connect to HLA and DIS, and we have tools also for manage the real-time simulation. Finally, we have a very powerful API that is very, very simple, that can go the same over HLA, DIS, or DDS. Well, SimWare Framework is a framework of simulation that goes over DDS, and this is quite important. The core communication is made in DDS, and all the communication, even the state machine, is done through DDS. With this framework, it's very easy to connect to HLA from Mac or from Beach, for example, and also to DIS. Well, the first thing we can do with SimWare is create simulators from scratch. We can start from the data model of the simulator, and we can create a full simulator without the user having to see any code at all. The idea is that with that, it's very easy to build a simulator that runs smoothly over DDS with very low latency. Of course, this is a very basic simulator. You can build that way. I mean, if you want to add something complex like a visual thing or whatever, then you have to code something. But if you want to make a basic simulator, it's very, very easy with our tools. You don't have to code anything. Our tools compile for you the libraries. Our tools build for you the models. And all the time, the backbone, the communication backbone, is the standard DDS. Well, for doing that, we have different tools. The first one is Modeler. This is the starting point for everything. You start from scratch. You can start here from zero. You can say, okay, I'm going to make a new model here. Or you can start from an HLA data model. There is a phone model. Maybe you already have your simulations running over HLA, so you have some phone models. So the only thing you have to do here is loading these data models. And then with that tool, you can modify anything in these data models, and then it's a matter of generating a library with that tool. This tool is going to create a library for you. And in this library, that is a DLL in Windows or a DSO in Linux, goes the same in Windows and Linux. DSLL is the translation of the HLA model to DDS. I mean, in the HLA you have publisher, things that are going to be published, things that are going to be subscribed. So here in the DDS we have things that are going to be published and subscribed in DDS. So we will have all the callbacks, all the publishers, all the subscribers in DDS. So now this is the basic. We have this library in DDS that is the data model. Well, second tool, and this is the tool of this webinar is about, is SimDeveloper. The idea here is that you can build and rebuild and reuse and use models, simulation models, and in this case we are here using MATLAB Simulink for doing that. This is a tool that goes into MATLAB Simulink, and the idea is, okay, you have your people that knows how to model, that knows how to build these simulation models, but maybe they are not so good coding, no? Or maybe, well, and this is a typical situation, maybe the coding they make is hard to reuse, and the only reuse you have on your organization is maybe copy and pasting, and this is not safe. So here we are based on a COTS, we are based on MATLAB Simulink. So all that people that knows how to build, how to create simulation models can work into MATLAB Simulink. And then what we are doing here is saying to MATLAB, okay, translate this model into code, into C code, and then we are wrapping this code with our layer that allows us to control it from DDS. And this layer uses the same data model you have used in the modeler tool. So this is the point. Very important thing here, we are not running the models from inside MATLAB, because this is typical in some tools. We are taking these models from MATLAB and then running them from outside. Well, that way it's very, very easy to reuse these models. It's very, very easy to go again and again and use your models from one project to another project, because we are using the COTS all the time. Final remark, and I will go further into that later. It's not mandatory to use MATLAB for using this schema. The idea is that we use MATLAB because it's useful, but if you already have your models, your simulation models running in C++, and they are time-driven simulation models, we can reuse them, we can put them into the same simulation. Well, third element is PowerLink. PowerLink is a tool for making data breaches. And here the idea is that you can avoid all the complexity of the data breaches. You can avoid all the complexity of the communication layer. No matter if you are running over DDS, HLA from Mac or HLA from Pitch, we are going to give you the communication layer build. So you don't have to care about the complexity or the difference between HLA from Mac, Pitch, etc. You only have to care about the data you want to communicate. So it's as easy as loading two phone models, one side and the other side, and deciding which fields are going to be communicated. And maybe, if you want, optional, put in some functions between these elements. Maybe you want to change coordinates or something like that. So with that, we are going to generate for you a program that is a gateway. So you can reuse easily these gateways, and you can avoid or skip all the complexity that goes underneath, all the complexity of how to connect to whatever thing. Of course, it's not mandatory to have data breaches. It depends on your simulation. Well, final element. With that, three elements we have seen before, you can create things without seeing the code. But maybe you want to add something here. Well, we are not providing you, for example, with a visual tool. Maybe you want to use, I don't know, Presagis or VR Forces or VBS2. And maybe you want to connect that with HLA. No problem. But maybe you want to make a more intimate integration. Well, in this case, we provide you with a library that is called SIMWARE Sim. And this library is an API that is very, very simple, but very powerful, because with the same API and just the same API, you can connect to DDS or to HLA from Mac or to HLA from Pitch with the same code. So with that, you have all the communication layer done. So you don't have to care about this communication layer. Of course, you need the data model, but you have this already made with the modeler output. So with the modeler output and this library, and also with the environmental variables that we provide, and also with the libraries, for example, for Boost we provide, you have guaranteed all the communication. You can care about adding your thing over this, maybe, I don't know, explain, maybe your own API, maybe your own tools. So this is the idea. Well, here we have a schema of everything running. It's very schematic. But this is the idea. At the beginning, we have a phone model. Can be a standard phone model. Can be the model you are already using. Can be HLA evolve, by the way. And the output here will be a library that is this same model with the objects and the interactions, by the way, with everything, converted into a DDS data model. That is a library in C++. It's already compiled for you. Second element, well, you can create with SimDeveloper simulation models. Later we will see how to run this thing. Third element, well, if you want, and this is not mandatory, you can create data bridges to HLA or DIS. In the case of DIS, it's even simpler than HLA because it's a matter of the PDUs you are using. And finally, if you want to add your own elements, you can use SimWare Sim plus the data model in DDS plus your C++ code or your API or whatever. Well, second thing here, we can manage these simulators we have created. And for doing that, we have two tools. One of these is a very, very complex real-time scheduler, and the other is a very basic control console. The idea is that we deal in SimWare with the core of the simulation. We are not in the business right now of computer-generated forces or visual tools. The idea is that we provide a basic console without gateways, without missions, without these kind of things, and a very complex scheduler. And if you want to add this kind of things, you already have a lot of tools in the market. You can connect using the API, or you can connect using HLA, for example. So this is the first thing, is the real-time scheduler. The real-time scheduler, that is called a scheduler, is into a set of two tools. The first tool is the scheduler itself, and the other is the simulation engine. And the idea is that the scheduler is a tool that is going to run all the show. It's going to do three things. The first thing is going to mark the timing for all the simulation. The second thing is that it's going to order the loading and unloading and creation of new simulation models. And these models we have made with the SimDeveloper. And the third thing is that it's going to command the state machine. It's going to say, okay, now stop, now start, now whatever. This scheduler, you don't have to care about it. You don't have to recompile it in any new simulation, because the idea is that the information for this scheduler comes from a configuration file. So at the beginning, when this scheduler starts, it reads this file. So all the information about the simulation itself is in this file. Later we will see this file in more detail, more close detail. But the idea is that if you change your models, or you change your layout, or you change your simulator, you don't have to recompile neither the scheduler nor the simulation engines. You only have to change the configuration file. Well, in this file is the name of the models you have to load and the frequency of the simulation in hertz. The second part of eHost is or are simulation engines. And the idea is that these simulation engines can be distributed in any other node in the network. And these simulation engines are going to ask to the scheduler what are the models they have to load. So they will load and command these models. Everything here, all the communication will be done by DDS, and the idea is everything, even the model, even the state machine, is communicated through DDS. So the scheduler is going to send the information to the simulation engines through DDS, and the simulation engines are going to load the models, the simulation models, and the models are going to load, are going to declare the things in DDS that they are going to publish or subscribe. So everything is done through DDS, and nothing is hard-coded here. Of course, the scheduler is not the tool that decides to start or stop the simulation. It's only the tool that controls everything. There will be another tool, and we will see it now, that will control the simulation. And this is the tool, a very basic console. And here the user can say, okay, now let's go to init the simulation. Let's go to execute everything. Let's go to stop everything. You can do three things with this tool. It's very basic. One of these is controlling the state machine. We have seen it. The other is loading and saving scenarios. But in this case, these scenarios are the layout, the instances of the objects of the simulation models you have made, and the parameters of them. But we are not here providing anything for gateways or for missions or things like that. Third thing, you can create and control new instances of the simulation models from here. Well, at the beginning, this tool asks, using DDS of course, to the scheduler, what are the elements that are going to be in the simulation? The simulation is going to be about, for example, planes and ships. So this information comes to this tool that is called ACS, and this tool is going to know about that. So now you are able to create new instances of these elements. You can create a new plane with changing the altitude, the position, etc., all the parameters. And then during the execution, if the model is prepared to do so, of course, because you have to prepare the model to accept this kind of orders, you can modify this same model. For example, you can say, okay, now the altitude of the plane changed. And you update, and this is updated in all the simulation at the same time, because we are using DDS for that. And also, you can delete these instances or create new instances with that tool. Well, let's see it in the framework. We have the ACS, that is the central console for everything. Can be distributed because we are dealing with DDS. Can be in any computer node. We have the host, the same. The scheduler can be anywhere. The simulation engines can be in other places. And then the user press init. And then this goes through DDS to the scheduler. And the scheduler loads the configuration file. So now the scheduler knows about the simulation, what is going to be into the simulation. Next step, the simulation engines will ask about this information, and then will load the simulation models they have to load. Now the user press execute, and the simulation starts. We have the ticks that are going to be sent by the scheduler. We have the steps that are the same, but it's the calculation for next step in the simulation for the models. We have the user interfaces or whatever thing the user has done with our libraries. And we have the gateways sending data to, for example, HLA to and fro. So this is the environment, the framework for SimDeveloper. The idea with SimDeveloper is that it's a tool for modeling. The idea is, okay, you have people that know how to model in your organization, but maybe they are not so good coding. Or maybe this is worse and you are only making these computer programs all the time that mix together the communication and the models there. So you have a problem there. You have a problem of reusability. You have a problem testing these models. You have a problem verifying these models. It's almost impossible to reuse or to grow these models. Scalability or maintainability is very, very hard. The idea is, okay, now here, use a COTS, use something like MATLAB, why not? And in MATLAB you have people that have experience modeling and can reuse models or blocks from other projects. So let them do that thing. And we will make the code for you. So you don't have to care about the quality of the model. Of course, if you want to test this thing, you can use MATLAB for that. You can test in the range of the simulation the input and outputs into MATLAB. And with that, what we are doing is that we are covering the typical V of development that we have in all organizations. The analysis, design, implementation, verification and validation, and integration. So at the beginning, you only have to care about analyzing your real system, deciding the model list, and establishing the data model. And this data model is going to be in HLA format. So you will have to decide the data model and the models that go there with it, with all the complexity you need, etc. So the implementation of that will be done with MATLAB. You create things in MATLAB with the blocks, with the complexity you have there. You put there the algorithm you need for calculating everything. And then we are saying to MATLAB, okay, give us the C code of that. And then we are wrapping that with our C++ class to do three things: to control the models, to create new instances of them, and to add them to DDS as publishers and subscribers. And the output is going to be a library in Windows or Linux, by the way, because we work all the same on Windows and Linux. So final step, verification and validation. This can be done from inside MATLAB Simulink. I mean, you don't have to test your code outside. You have to test you can test your model inside, so it's easier. And then you can build any complexity simulation you want to do. And this we have already done in a lot of projects these days. Of course, this can go also with HLA, or we can connect with COTS, like for example VR Forces or VVS2. In the case of VVS2, using LBC Games as a gateway, or Presagis. We are integrating these days with Presagis tools, Vega Prime, Stage, both using HLA or the APIs they have. And now, before going to eHost, I'm going to show you the SimDeveloper thing. So now let's change to this one. Okay. So this is it. I have started MATLAB. And what we have done is adding some tool inside my lab. It's a library inside my lab, MATLAB, sorry, that is called SimDeveloper. Here we have two kind of things. We have blocks, just for helping people doing things with that. And these blocks are very useful. And we have tools like the manager. We have here the manager. And the manager is an interface inside MATLAB. So we have MATLAB as is. I'm going to close that. And now we have this interface here. So what's the idea? We can work here two ways. The idea is, okay, you can do things the way you do usually in MATLAB, make your models here, etc. But then what we are providing here is wrapping this thing with the same data model you decided at the beginning, with the same data model that comes from the phone model. So here we can work in two ways. The first way is just loading a data model. That is a phone model at the end. It's part of a part or all the phone model if you want, because we are using DDS, so it's not mandatory to use all the data model here. You can use only a part if you want. So for example, I load one of these. We need a name, we put it a name. We need a place to put this thing. Now I'm putting it into any directory will do. It's going to be load. And now I can add it to Simulink. And here, what we have is just the inputs and outputs of the data model. And in DDS, this is going to be the things you are subscribed to, and these are the things you are going to publish. So these are the things that your model needs for working, the inputs and the outputs. And now, if we go inside, we will see that inside, right now, we only have this phase thing. We have the state machine thing, just for controlling the state machine, but nothing else is void. So now the idea could be your people building these insights of the data model and later generating everything. Well, this is the first way of working. The second way is, okay, maybe you already have the model in MATLAB and the wrapper, the data model in this case. So you can load both. For example, I have here one of these. You have the MDL, that is the model in MATLAB. And now I'm going to load a data model. Well, the idea is that you are going to connect all these inputs and outputs to your model. Of course, it's not mandatory. You don't have to connect everything. But well, the idea is that if you are loading a model, it's because you are using it. If not, you can delete something from here, of course. Here we can see this is quite different. Here we can see that this is full of logic in this case. We have everything here for the launcher thing, etc. So this is the second way of working, is working in your model and connecting to the inputs and outputs. And now, what we can do is, okay, we can verify that everything is connected. We can verify that all the inputs and outputs are connected, and this is very important. It's not mandatory to connect everything, but the idea is that maybe you want to connect everything because you have decided to add these inputs and outputs. So you can verify that here. And the second thing you can do is generating this as code in Windows or Linux. And the idea here is, okay, we are going to tell MATLAB Simulink, okay, give me your model in C code, and I'm going to add a wrapper that I'm going to build on the fly for controlling it with that inputs and outputs. So I press on generate code. It needs a place to put the output. So for example here, now it's starting to generate it. As I mentioned before, we are not running the models from inside MATLAB, but from outside MATLAB. Well, we don't need any variable here, so let's build it. And now it's going to do, well, first of all, it's going to create the C code. And the second thing is going to build this as a library in Windows or Linux. For building it in Windows, you need Visual Studio, and in Linux is GCC. And also it's going to give me a summary of everything as an HTML report. And I'm going to show you. Well, here we have the report. Well, it's asking me for the place to put the final library. So here we have a summary of the code. Here we have our wrapper. This is the wrapper we are using. This code has been generated on the fly. Here we have all the connection methods for initializing everything, for calculating a new cycle. Here we have the step thing, that is the key element in MATLAB. Now is the calculate a new step. We have the connection for the inputs and outputs here, etc., etc. Also, we have here the code for creating new models, new instances of the model. From outside, we will be able to say, okay, now create a new plane with these parameters. So this is the code for doing just that. We can delete the model. We can, well, and also this is quite important. We are declaring here the things that the model do in DDS, the things that are going to publish and subscribe. So the things the model needs for running are the things that is going to be subscribed, and the things the model wants to publish are the things that are going the outputs of the model. Here we can see this code. This code is generated by MATLAB, by the way. It's not as clear as our code, of course, but you don't have to care about that, because you can do your testing, your verification inside MATLAB, and then you can recompile this code again and again. So you don't have to care if this code is elegant or not here. Well, and this is the MATLAB. So let's return to the presentation. Now we are going to talk more about eHost, because it's the key element for controlling these models. Well, the idea is that we have a scheduler, and the scheduler is used for controlling the real-time clock, for the state machine, and for creating and modifying and deleting these models using the simulation engines. Very, very important, the file, the key file. This is the file that the scheduler is going to load at the beginning. And here is all the information about the simulation itself. Well, it has a lot of information especially for the models. Very important here, the frequency of the simulation is here in yellow. You can see it in hertz. You can see here the layout of the simulation, because you can see here the names of the simulation engines, and these simulation engines can be anywhere distributed, and also which models goes into which simulation engines, and these are the names, these names in green. So if you want to change your model, it's very, very easy. You only have to change this thing here, this name here. And since we are using DDS, you don't have even to care about the data model itself. I mean, the new model can use more or less elements of the data model than the previous one, because it's a matter of what you want to publish or subscribe. It's not mandatory to publish or subscribe everything all the time in DDS. So maybe you are changing this model to another model that is more complex, for example, now takes care about a thing new that is the wind velocity, for example, with speed, wind speed. So it's as easy as changing the name that you have here. Even this new model can use as part of the data model that no other element on the simulation knows about. It doesn't matter at all, because DDS doesn't care about knowing all the time all the data model in every node. Well, another key thing here is the wrapper file itself. Well, this wrapper file is made on the fly, but at the end it's only a file, it's only a class. With that, you can control the state model with using DDS. You can control the things that the model publish and subscribe. You can create new instances of the model. And also here you link with internal methods. Well, what happens if you don't have MATLAB? Well, then what happens is that we can connect this thing by hand in this case. If you have some models in C++ that are clock wall simulations, that are time-driven simulation models, then maybe we can connect that. And of course here there is no guarantee. Maybe we can connect that with that layer. It's a matter of finding the points where you make the steps, where you make the terminate, where you make the methods, the internal methods here. We already have the environmental variables for compiling that. We already have the dependencies in terms of libraries, and this is very easy because our dependencies are very, very, very light, no, and can run over a lot of operating systems, by the way. So if you have a model, already system model, maybe we can reuse it. If not, if you are using MATLAB, okay, then you can use SimDeveloper as is. Well, and this is all. If you want to try SimDeveloper or you want to try SimWare Framework, you can ask us for a trial of it. Well, all our tools can run the same over Windows and Linux. We can recompile them over another operating systems if you want, because the dependencies are very low. The only thing that goes only over Windows is SimDeveloper. Right now, we only distribute SimDeveloper on Windows. We have a distribution of SimDeveloper from MATLAB 2004 to 2010 right now. So if you want to try it, just send us an email and we can send you the keys for downloading the code, a temporal evaluation, a temporal license, sorry, and you can test it. Well, and this is all. Thank you very much, and bye.